In this lesson, we're going to look at the Quicksort algorithm, which is another divide and conquer algorithm for sorting data. We're looking at an animation of it now. What happens is in a Quicksort, you pick a pivot point. The pivot point then becomes a tool for comparing values. Notice what we're doing is we're sorting values to be on either side of the pivot point, 3 being the pivot point, depending if it's less than or greater than the pivot. Now 1 is chosen as the pivot because we're continually bisecting the array. The pivot is always found as an approximate midpoint until the data is sorted. So now we see that 1, 2, 3 is sorted. It's going to pick another pivot. Everything's in order. Now it picks another pivot 4. It compares it with the other n 5. Those are out of order, so it swaps them. Now it looks at 8 and 6 and 8 and 7. Those are not less than 4. Now the new pivot is 6. 5 is less than 6, so 5 and 8 are going to be swapped. 7 and 6 are also out of order, so 7 and 6 are going to be swapped. 6 and 7 are in the right order. Now it picks a new pivot 5. 5 and 6 are already in order. Now it picks a pivot 8. 7 and 8 are already in order, so nothing else has to happen, and our array is sorted. So let's look at how to implement the Quicksort algorithm. I've already begun a program. Let me spread it out just a little bit here. I have a display method to display the contents of an array, and then we create an array, and we call a Quicksort method to sort it. So all we have left to do is implement Quicksort. So let's get to that. We're actually indented just a little bit too far, but I'm not going to change that. That'll be fine as it is. So our Quicksort method takes 3 parameters: the array we're trying to sort, a left value, and a right value. So if you see down in the method call, left and right are always the lower bound of the array and the upper bound of the array. That's the starting point. The first thing we do is we take left and right and assign it to some variables, I and j. Next, we create a temp variable we're going to use for swapping. Then we compute our pivot. And as you'll see, the pivot is chosen by taking the left and right values, again 0 in the upper bound of the array, and dividing by 2. That gives us an approximate midpoint for the array. So now we begin the process of sorting the data. If the data is already less than the pivot, which is what we're looking for right here, then we simply keep moving. And if data on the right-hand side is already greater than the pivot, then we move down and don't do any changes. Otherwise, we swap. And then increment I and decrement j. Close the if, close the while. Now, because we're doing segments of the array, we may need to call the Quicksort method again. Most times we will, as you saw in the animation earlier. So here's where we recursively call Quicksort if we need it. Just like so. And that's all we have to do. Okay, so here's our method definition. Here's our program again. We create a simple array of 10 elements, print out the unsorted array, call Quicksort, and then display the sorted array. So let's save our file. Open our command prompt window. Let me clear the screen there. Now we're ready to compile the Quicksort program. It compiles just fine, then let's run it. Here's our unsorted array, 5, 10, 1, 9, 4, 8, 3, 6, 2, 7, and our sorted array, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, Quicksort is a method that we should use on large data sets, and it works just fine with small data sets also, but certainly should be used when a large data set is presented, and most library sorts implement the Quicksort algorithm for sorting. so it's clearly the preferred method for sorting data. And with that, we're finished with this lesson, and we're ready to move on to the next lesson where we're going to leave sorting for a while and move to searching algorithms.